In this video, I want to have a look at misleading data. So data can be misleading for lots of different reasons, and sometimes that can be intentional or sometimes it can be unintentional depending on the people that are collecting and presenting the data. So one of the things that can make data misleading is if we have a really small sample size. So if we only collect data about a really small group, then it's not going to accurately represent the data for the whole group. So the whole population, sorry. So the bigger the sample is, the more accurately it's going to represent the population as a whole. The second reason that things can be misleading is if a sample is biased. So that could be lots of different things as well, like maybe we're looking at favourite sports and we only ask males, not females. Or maybe we're asking about uniform preferences and we only ask seniors and no juniors. So biased samples don't represent the whole population. A third way that data can be misleading is if our graphs are poorly drawn. So if we're displaying the data, but it's not accurately representing the true data. So poorly drawn graphs might be that the axes aren't labelled, so we don't have any units, we don't know what the graph is representing. It could be that the scales on the axes aren't consistent, so it might go up by 50 in one step and then go up by 100 in the next, or the scales might not start at 0. There's lots of different reasons a graph can be drawn poorly, but that's just 3 of them. Let's have a look at a few examples. Our first one says a school surveys 15 students to collect data about student opinions on the uniform policy. Is this data likely to accurately represent the opinions of the whole student population? What could the school do to make their data more accurate? So if they're trying to collect student opinions about the uniform and they're only asking 15 students, it's not going to be very accurate. So that those 15 students might end up only being senior students or more boys than girls. And only asking such a small group doesn't necessarily mean that all the opinions are going to be represented. So to improve their data, they could ask a larger number of students. Our second example says a company wants to collect data on people's favourite TV shows, so they conduct a survey at a local shopping centre during lunchtime. Is this sample biased? So if you think about the sort of people they're going to be asking, they're asking at a local shopping centre at lunchtime. If that's during the week, and it doesn't say that it necessarily is, but if that's during the week, then you're only going to get certain people. So people who don't work 9 to 5 jobs, people who can go to the shops in the middle of the day on a weekday. So you're missing, say, school students, you're missing people who work most of the time. You're going to get people like people who work unconventional hours or people who are retired or people who don't have jobs, who aren't employed. So is it biased? Yeah, it's likely to be. Okay, now third example says which of the graphs below is accurate and why is the other graph misleading? So they're both showing us the same data. They're both showing us sales of dog food. They're saying that the brand Doggos sold 120, bags, boxes. This one doesn't say. Over here it says thousands of boxes. So this one must sell 120,000 boxes and this one sells 140,000 boxes. So what I'm thinking already is that this one's going to be more accurate because when I started reading this one, I didn't know what units that was in, but over here it really clearly tells me. The other thing that's important about this one is that this scale doesn't start at 0. So at the moment, this column looks like it's twice as tall as this one. So it looks like they're selling twice as many munchies as they are doggos. But 140,000 isn't double 120,000. So when they start the scale at 0, you can see that the difference isn't as drastic. So this one over here is more accurate. And the reason that this one, some of the reasons it has an issue, is the axis isn't labelled. And the axis doesn't start at 0. So that's having a look at some ways that data can be misleading.